bring agility to how we manufacture and allows us to rethink our approach to new business opportunities. If we look at this simplistic view of the AM value chain, it obviously begins in the digital space where we can add complexity, unique surfacing, and more attributes. It then transitions to the build phase where printers are enabled with high performance materials and advanced processing methods. Finally, through technologies like what we offer at DyeMansion, we now have this more sophisticated approach to finishing our raw parts to deliver a premium value to our customers' product and or their industrial component. The rest of this presentation will look as follows. I'll go into some details as to who we are at DyeMansion, the print-to-product workflow platform, as we call it, and I'll take a deep dive into our technology segments as well. At DyeMansion, it's our mission to continue to be the global leader in post-processing solutions for polymer 3D printing by turning raw parts into high-value products. DyeMansion was founded in 2015, headquartered in Munich, Germany. Our North American team operates out of Austin, Texas, and globally to date, we're right around 100 or so people, and we have about 700 systems or more installed worldwide. It's our vision to make 3D printed products part of our everyday lives, enabling tailored solutions and driving towards a sustainable manufacturing. This is all achieved primarily with the people in our company and the great technologies we have produced. We then fortify this with our great partner network of OEM 3D printing companies and great resellers like AdvancedTek. As showcased here, today we are the only provider of a full workflow that offers an end-to-end solution for advanced finishing. This includes cleaning, surfacing, and coloring. Again, it's the technology and our methodology that allows us to bring high value to the raw 3D printed part. So let's look a little bit more at this print-to-product platform. You're going to see this image quite a bit in different segments throughout this presentation, but this represents our full workflow. It's broken up into 3 stages, as I previously mentioned: cleaning, surfacing, and coloring. So depending on your needs, 2 to 3 of these systems will enable a company to unlock that added value of advanced post-processing. When looking at the benefits of our print-to-product workflow, you'll see it delivers high-quality parts from a technology infrastructure that is not only versatile, but automated and scalable with readiness to support Industry 4.0. We've already found proven success within various industries that is largely due to our agnostic approach to materials and geometry, with a focus on building robust systems that achieve reproducible results, which further provides a cost value to our customers. The DyeMansion technologies are quite versatile when it comes to supporting printing technologies in the wide range of materials in the market. With that, we primarily focus on the polymer powder bed technologies like that of SLS, MJF, and SAF, where we can process the many flavors of nylon 12, nylon 11, and TPU materials. We've been expanding our smoothing capabilities into the filament space with advanced materials like Ultem, ABS, and nylon. We even have limited dye capability with the EPU resins from carbon. Given that versatility, you'll find us involved in many industries to include automotive, general industry, of course, consumer goods, and healthcare. And these are just some of the companies that we've worked with and have established product designs around. What you see here is kind of how that print-to-product workflow can be applied to a printing technology segment. So again, beginning with that digital phase where they're using advanced surfacing technologies like in topology, along with 3D designs like GrabCAD. Once you have your digital component, you send it to a printer like that of the Stratasys H350, their new SAF technology. Once the parts have completed building, you'll do a light decaking or depowdering of the part. So you're just getting that bulk material off, and then you'll put that part with still powder on it inside of our PowerShot cleaning system, also known as the PSC. From there, it'll run an automated process of about 10 minutes where the parts are tumbled in a rotating basket or drum, and a cycle of compressed air and blasting media is applied to the parts. Once it's done, it's what we call a clean, raw, as printed part. From there, depending on what kind of surface finish you're looking for, if you're looking for something closer to the raw part where it's still granular, and not a completely smooth or high gloss part, you'll want to take this top line where you'll actually apply color first, and then you'll run it through our PowerShot S surfacing system, which uses a different media than we offer in our cleaning system, and provides just a more homogeneous surface finish that locks in the color and has this like satin type sheen to the final surface. If you wanted something a bit more robust and higher gloss and improved sealing, moisture avoidance surface, you'd actually take this bottom line. So the part would actually go through our vapor fuse surfacing system. So this is a vapor chemical exposure process. The parts are suspended, processed, come out smooth, and then we would then do the final application of dyeing for color. To look at it more specifically within like a part characteristic here, these three parts kind of showcase those options there. So the very first part that you see, this clip design by Stratasys, you've got the raw part. You'll see that it has this bit of fuzziness around its like edges, while having a surface that's vulnerable to moisture absorption and dust collection. The middle part has been processed with our DM60 with a black dye, and then treated to that PolyShot S surfacing system to lock in a more robust finish. The last piece has been processed in our vapor fuse smoothing system, and then also dyed in our DM60, which has a more injection molded like finish that is also sealed from moisture. So let's take a deeper dive into our actual technology systems, and we'll begin with the PolyShot cleaning PowerShot C. So the first thing to consider here are the risks of what we call manual cleaning. So these are your standard bead blasting cabinets, very low cost. They often are kind of like the standard issue that a 3D printing supplier will provide. They work, but they have many flaws. Largely, you're dealing with with parts in one hand and a compressor gun, blasting gun in the other. And what we find are typically these issues here. We find fingerprinting, and that's just from holding the parts and not having a consistent pressure, so you get this little shadowing effect. Powder residues, so this is from possibly insufficient maintenance on the machine, to where the media is just not being as effective as it can be. And then we see these burn marks. So this is from overpressurization or over cleaning of the part. And on raw parts, sometimes they're hard to see, but when we look at the steps down the line with post-processing, particularly dyeing, these shadowing effects that you see here or poor cleaning results will show through as defects down the line, particularly in systems like dyeing. So our solution is the PowerShot C. It's becoming the industry standard for easy and efficient part cleaning. It's an automated process. Once you load the parts, you close the door, select your cleaning program, which can be anywhere from 3 minutes to 10 minutes is typical, but you can also do custom programs up to 15 and 20 that you can create as well. And it's going to run back and forth between media being blasted and compressed air to always keep that part clean and allow the media to be effective on it. As you can see down there in the bottom, the system as is has the capability to support like a typical build size, about 3/4 of a full build from a P3 system, an HP 5200 system, or it can take a full-sized H3 350 build volume. So a little bit more a rendering of what's going on inside the system here. So you see we start with a part lightly covered in powder still, and then the media is applied, breaking it down. and kind of on a microscopic level, just like with like a standard cleaning process, you're still left with this what we call like a microfilm of partially sintered powder. And this really is where like the moisture absorption and dirt and dust collection happens on a as printed clean part. Is this microfilm of powder is easily impressionable and is just kind of there to absorb anything that comes in contact with it. And then you're left with, like I said, this standard of what everyone interprets as a raw printed part. When looking at the value and space savings that the system has, one PowerShot system can replace the need of 4 manual systems. It will also support typically about 3 to 4 printing systems as well. And generally, you just need one operator to maintain and support the operation of a PowerShot system. So now the very similar but different PolyShot surfacing PowerShot S platform. So as you see, very similar looking system. It's built off the PowerShot C architecture. The big difference here is the media and blasting strategies that we apply here. So we use a different media in this system in terms of what the actual material is, as well as particle size. But it offers all the same advantages in terms of automated operation, defined programs from 5 to 15 minutes, as well as the ability to create custom programs. And it has the same capacity capabilities as the PowerShot C. So what this is really doing is once your parts have been cleaned, and like a system like a PowerShot C, you run it through this system here, and as you can see now with that microscopic view, like the layer view, that microfilm of powder has been removed and or compacted further into the surface. So you just get this cleaner, more scratch resistant, and even partially sealed surface finish that's just more homogeneous and aesthetically pleasing to the human eye. To look at it again in kind of different stages, different materials, you'll see like the top there with like a white base material. You go from like the high granularity of the raw part to slightly smoother with the PolyShot S. And then you can see where like the shine really comes through and the finish really comes through once color has been applied. Same thing on the bottom. With gray parts, you'll actually see the part get a little darker after it's been exposed to the PowerShot S phase, and that's just because it's taking away that raw white material that was on that surface. And then these are some application highlights worth noting. So we have like an automotive, consumer parts, industrial components, a lot of consumer products and prosthetics. So all of these were digital surfacing being applied, nice pop colors, custom colors for like flesh tone matching. You can just see here that all these products, while 3D printed, very much look like the industrial injection molded components that they would be mimicking otherwise. And this is what kind of makes it the leading blasting system for end-use parts to achieve superior finish. It's one of the most cost-effective solutions to achieving like a high-performance finish as well. So this is just further examples of that capability. Further in the PowerShot series of machines, we have our new line that we brought to market this year. It's actually machines are starting to deliver in this Q4 segment that we're in now, and that is this new performance series. So it's available in the individual flavors of being an independent cleaning system and an independent surfacing system, but we now offer in this new dual system here that has the ability to do cleaning and surfacing in the same system. One of the big process improvements to this technology, the PowerShot technology, is this change to what we're calling the multi-belt. So this is a much more versatile processing chamber. It's much larger, and it's more accommodating to a wider range of geometry, including small parts, large parts, and fragile parts. And you can see there, just on size alone, You can see how much bigger it is compared to like the processing capabilities of the established printing systems I've mentioned before. Space saving wise, so if you're looking at the dual performance to replace the option of buying two individual machines, you can see it roughly saves about 50% of the workspace compared to the footprint you would be required to have for a PowerShot C or S system individually. And then overall, this system was kind of built further towards that Industry 4.0 and Factory of the Future. So it has, a similar but more advanced graphic user interface, and with the way the multi-belt functions, it can also assist in automatic unloading of process parts as well. So now let's look at our VaporFuse system. So the VaporFuse is our smoothing technology. We offer that in two series as well. So newly announced last year at Formnext and coming to market through 2023 in delivery terms. We have the PowerFuse S, the system that we've had available, since 2019, which is our standard system. It's the most versatile. It was developed for processing PA12s, PA11s, TPUs, the filament materials. It's one solvent system that treats all of these other materials. And then we have the PowerFuse S PP for polypropylene. So this is a specific system for processing polypropylene materials only. We will further develop this system to see if other material applications exist with the special solvent in this system, but for now, we're launching it as a PP exclusive system. So yeah, the main attributes that we offer here with the PowerFuse S, beyond its true capability, it's a green technology. It's a single solvent. It's a green solvent as well. So and it's a closed loop system. So the solvent is not a consumable that our end consumer needs to store or have any kind of hands-on interaction with. So it's just easy to handle, and there's no concerns about a need for PPE or anything like that in the operation environment of the system. Ultimately, it's delivering sealed and smooth surfaces, so this benefits any need for air tightness, bacterial protection, and some part strength. It's eco-friendly, it's a non-CMR solvent, and if you're using the right printed materials, it's approved for food contact. And again, with the automatic loading feature being able to run 24/7, you've got this automatic loading, unloading capability for a lights out operation. Typical process time, as you see here, is anywhere from 90 to 180 minutes, and that largely depends on the material limits as well as like the surfacing levels that you're trying to achieve. Inside the system, you have your clean parts. The solvent is introduced as a vapor. It condensates and settles on the surface of the material. It kind of opens up and then relaxes the material surface, and you're left with, as it finishes process, you're left with a nice, smooth, sealed surface. As I mentioned earlier, so another unique capability of the DyeMansion technology here with the PowerFuse is our ability to have iterative smoothing levels. So out of the gate, we offer 3 levels of smoothing, what we call light, balanced, and strong. But these are actually smoothing levels that can be fine-tuned ultimately by the customer to where if light is too light and balanced is too strong, they can make a custom programming to find like that sweet spot in the middle. And then just as well, just to show you like more graphically here, there is a difference between the levels that we try to achieve here. So you can see there's a significant reduction in surface roughness going from raw to light to balanced to strong. And then these are just some showcase examples of where this smoothing technology has been applied to different materials and processes. So again, you can see the part there on the top left. It's still maintaining great feature detail on something like a foot orthotic where you're going to want a smooth, clean surface to keep any kind of antimicrobial properties. and then anything else from needing to be airtight, sealed. TPU materials typically continue to kind of like de-powder after they've been printed. So smoothing TPU materials is a great way to just kind of maintain their mechanical characteristics as well as improve like their tear strength. And then this is our vapor fuse, just a kind of like a highlight on the PP system. So you can see there a comparison between the raw part and the final part there. Again, it's offering all the same capabilities of having a sealed surface to improve, air tightness and locking out moisture on the part. And then on a unique part like this manifold here, exclusive to our vapor smoothing process in general, is the ability to penetrate into chamber volumes or deep lattice structures as well. So now for our DM60, our deep dye coloring system. So this is your opportunity to color your grays. So what you see here are like the 17 colors that we've established for the SAF technology, which are also available for the HP MJF technology as well. And for other systems that are like white-based materials, we have color systems established for those, including an expansive RAL code color matching capability as well. From a product line standpoint, our DM60 is one of our more expansive systems. So we have our DM60 full color. So this is going to enable you to run everything from black to the full color systems that you saw previously. If you're looking for a little bit more value and you feel like you only need to run black parts, we have the DM60 Black. So it's a slightly decontented system to run just black, but if you felt like you needed color later in the future, it can be upgraded to a full color series. And then further optimization of improving kind of like the cost value perspective of running black only, we have this reservoir tower. So this is an add-on to the DM60, which allows for the repeated reuse of black cartridges up to 5 times. And then the last system you see here is our reverse osmosis system. This is just for maintaining water quality going into the DM60. If you're familiar with pizza, just like pizza, the water counts. So when making the dough, so just for the DM60, it's really important that the water quality meets a certain level to maintain consistent quality in the final dyeing process. So the DM60, we have this wide range of color options if you kind of consider all of our material capabilities from white-based parts to gray-based parts, as well as like, PA12s, 11s, TPUs materials. We have a wide range of color capability. These are exact formulas that we produce, which means that they're reproducible and offer traceability for the process, kind of if you were implementing multiple machines through multiple factories. And then our colors and our production of those colors are all ISO certified. Typical runtime is about 2.5 hours, and much like the power shots, we can support about 3/4 of a build volume for an USP3 or up to a full-size build volume for the H350 from Stratasys. Inside the system, parts are introduced to a water bath, basically, where the dye is then mixed. It's chemically bonding to the material here. And you can see this like penetrative, depending on the material thickness and chemistry and process time. You'll see anywhere from 100 to 300 micron penetration depth of color, which means it's going to be much more scratch resistant than any kind of other coloring method out there. Speaking of other coloring methods, we're often compared to the pot dyeing technologies out there or methods. So what are some of the advantages of our system? It's much easier to operate. It's as simple as loading up parts, and it's kind of like the interaction that you have at a self-checkout at a grocery store. You scan the cartridge, it recognizes the processing recipe, sets all the parameters. You hit the function to lock the door. And once that door is locked, it's going to run its automated process, which includes cleaning, which is a big advantage to our system versus pot dyeing, where pot dyeings are very manual systems and often require some level of cleaning maintenance to be performed manually, whereas ours is more of an automatic introduced system with a cleaning agent. So more about that color and cartridge system and the reproducibility and traceability that we're able to maintain. So each cartridge is specially developed and mixed. There's an RFID tag. Within that RFID tag is all these part specifications that you see here to the left. So this factors in the geometry, the build process, the materials, and like ultimately the finished surface that you're looking to achieve. So do you want a PowerShot S surface, or do you want a vapor smoothed surface, or is it being tumbled from like an outside provider? We take all of those factors in consideration when developing colors for our customers, and that's all baked there into the RFID tag, which ensures us these reproducible results when anyone's building at scale and volume. More comparatively, a big advantage is just our color robustness, if you will. So when exposed to UV light and temperature environments, you'll see that we're able to maintain color vibrancy much better, much longer than what a traditional pot dye system can maintain. And again, as opposed to something that's coming out of a box that you can buy at a local hobby or fabric store, or something made for textiles, these are all specially developed color formulas. Our production method is ISO certified, and then we test against all these different ISO levels and industry standards related to biocompatibility, color fastness, scratch resistance, and light and heat resistance. And these are all documentations that we can provide to customers upon request. So again, that DM60 reservoir, so if you were looking for a high volume black coloring option that was also kind of cost effective, this is what you would select with like the DM60 black. It can also run with the full color series as well, but your best value is that combination of the DM60 black with the reservoir. So what this allows is, from a single special cartridge of dye, you can reuse that dye up to 5 times since it will be stored inside of that tower. So this reduces the amount of waste stream that it creates, and then it also saves time in the processing time for each cycle, once it runs. And typically, you'll see about a 37% improvement in lead times. 37% reduction in costs, and about a 30% improvement in lead time. That concludes our deep dive into the technology. Just to kind of summarize here as I close out, additional services we provide to our customer are my role, application consulting. So this is where we do our knowledge transfer. We do training on the technology, advanced training on the technology to further enable our customers, as well as providing the traditional types of service and technology enablement. So making sure, helping our customers with on-site support and remote support to troubleshoot any kind of issues they may be having. So that concludes my portion of this presentation.
Great. Thank you, Lester, for that overview. Reminder, if any of you have any questions for Lester, just enter those in the chat and we'll get to them at the end. And now we will turn things over to David Kadlec, Senior Application Engineer here at AdvancedTek, to share his recent customer success story.
Awesome. Thank you, Heather, and thank you, Lester. Can you hear and see my screen okay? The thumbs up? Perfect. Well, good afternoon, everyone. I'm David Kadlec. I'm a Senior Application Engineer here at AdvancedTek, and I just want to share a story of kind of how we use the new Stratasys H350 printer combined with the DyeMansion workflow to do kind of a high volume production run. So just if you're not familiar with AdvancedTek, we've been a Stratasys channel partner for over 25 years. And so we're based out of St. Paul here and been serving the upper Midwest. And most recently, the past year or so, we've partnered with DyeMansion because with these new high volume production style printers, often the bottleneck is in the post-processing side. So we've been able to see a lot more doors and opportunities opened because of the advancements in post-processing. So just to give you guys a kind of a recap of this story. So we're not really a traditional service bureau. We have all the demo equipment in our St. Paul lab, but we do use it to do some parts for people to help drive direct access to these machines. So we actually had a repeat customer come to us and say, hey, you made this part for us before out of FDM nylon 12. Can you get me another 1,700 units in 1 to 2 weeks? I'm like, holy cow, like that's a very short lead time for this quantity of part. It's really just a 3-inch clip or bracket for basically in terms of on their equipment, it helps guide a substrate into their machines, and it needed to be strong and accurate and consistent. These little snap clips they have some very small features you can see on the screen, so it was important that we maintain those tolerances and those features throughout the entire process, and they also wanted them to come in black. So that was kind of where we were starting with. So we're like, okay, we made these parts previously. Obviously, we're not going to be able to meet your requirements for timing if we stuck with FDM. It would have taken us 4 to 6 weeks to do it, and they needed it in 1 to 2 weeks. So that was kind of the main problem there too. And if you're familiar with these kind of short run types of parts, the lead time and the cost to get an injection tool made is often quite high. So that's where people are typically looking to get these parts 3D printed. And now with the new Stratasys SAF nylon 11 printer, we were able to handle this request in the DyeMansion PowerShot C and the DM60 for the post-processing. So that's kind of where the problem originated and kind of how we were able to drive to a new solution using Stratasys and DyeMansion. And you can just see here, this is on the screen here on your right, that's the nesting chamber of the H350. So we didn't even have to use half the build chamber to process 1,700 parts. So kind of why did we pick Stratasys and DyeMansion, right? I kind of said earlier it's a new high volume printer. So it's got a print head, and it doesn't matter if I have one of these clips or if I have 100 of them on a layer. My build time is purely on the Z height of my build, so that print head is passing over the same area whether I have one part or 100 parts on that layer. So that's how we're able to get the really high volume throughput with this new printer. And the important part is that this printer produces really consistent results. So these little tabs and fingers came out perfect every time. And then the PowerShot C from DyeMansion that Lester was talking about earlier, the first product, we use that for the automated residual powder removal. Because otherwise, as he mentioned, you would be standing in a blast cabinet for probably several hours processing these parts. And then the DM60 from DyeMansion was used as a final step to dye the parts and give them a consistent uniform finish. So this is just an overview of the workflow. It was an 8-hour print with a 16-hour cooling period. So literally one day before we could get to our parts, which was incredibly fast. And then we did the bulk powder removal. And for those who have never done bulk powder removal, it's kind of like the powder comes out in almost a cake form, and it's like a fossil dig. And you remove the bulk powder from it, and then that residual fine layer powder removal is done with the blasting process. And the PowerShot C makes that very seamless and hands-off. And then finally, we topped it off with the DM60 deep dye color black. And that all those steps took about 15 minutes to 30 minutes outside of printing, which was really nice. And most of that time is hands-off as well. So I have some close-up pictures here. You can see the residual powder, that white film after the bulk depowdering. You can just imagine having to bead blast one of those off for 1,700 of them would take quite a bit of technician time. And simply by loading them into the PowerShot C, we were able to achieve a nice clean finish. Those are the parts in the middle there. And then finally on the right, we have the parts dyed black. So really the value proposition kind of came from two different places. One, on the printing side, we were able to produce a high quality small part in a much higher volume than what we were previously able to do. And that's not a knock on FDM either, right? We use FDM for bigger parts, and if you need one or two parts, it's very effective. But we're finding if you want to do volume production of high quality small parts, this new Stratasys H350 works wonders for that. And we were able to reduce the build time from almost a month down to 1 day, and not even using half the build chamber, which is just wild to me. And then the DyeMansion on the post-processing side, there's a good chance people would maybe look the other way or just bite the bullet and have their operators work overtime to process a job of this size and magnitude in the time that they needed it. We estimated it would take over 6 hours, nearly a full day of work to process this job if we were to do it manually. Instead, it literally took 30 minutes, which most of it was just watching the PowerShot C do its thing and loading and unloading it. So, and then to top it off, it's a great part, but this customer, it was going to be a customer facing part, so they wanted to dye it black and color it. So that gave it the boost in UV and scratch resistance as well. So really, at the end of the day, this combination opened up a new revenue stream and new opportunities for us to do high volume work and quick turn jobs, which is what we're seeing our customers start to use this technology for in the field, to produce high quality end use parts that meet several requirements in a way that reduces post processing labor as well. So that's really all I have. I'll turn it over to Heather to moderate some questions.
Thank you, David. That was a great example showing the benefits of the DyeMansion finishing systems. So we'll go ahead and take some time for questions. Remember, if you have any, just enter them in the chat feature at the top right of your screen. And we have a couple already here. The first one is, what kind of limitations do you have for colors? Lester, that'd probably be a good one for you.
Yeah, no, that's a great question. So, yeah, as you kind of saw, that we have a wide range of color capability. If you're using white-based parts, that's probably where the most wide range capability exists today. So we have like the standard 17 color line established, but then we also offer these unique neon and automotive grade colors. In addition, we have 170 plus RAL codes developed for the bright white based color products out there as well. And then when you look at your gray based parts, we offer these like 17 colors again as a color system. But unfortunately, when it comes to the gray-based parts, because you're starting with that gray, it's difficult to create custom colors, much less color match when you're starting with that kind of base tone. Particularly on the HP MGF side of things, we see like a high variability in that base tone to where it's multiple shades of gray from a single build. So you can imagine if you're trying to color things uniformly, like a single color like red, if you're getting multiple shades of gray as your base, you're going to end up with multiple shades of red equally as well. So that's just a testament to how important consistent print quality is. And we definitely see an advantage in the SAF direction to where their color tonal differences is much tighter.
Okay. Next question, what other filament besides Ultem can you support?
Yeah, so I mentioned we do Ultem, ABS, and nylon. We also have some parameters developed for ASA, including like the variations of those materials. So Ultem specifically is like the Stratasys 9085 and 1010 variant. ABS would include like the standard ABS as well as some of the filled variations. Same thing for the nylon. So whether it's the standard nylon 12 or the nylon 12 carbon fiber filled, we can process those as well.
Great. Next question. For black dyed SAF parts, how do the dyed surfaces respond in the presence of oil and or grease, specifically mineral oil and white lithium grease?
Yeah, so I imagine white lithium grease isn't too much of an issue. At the end of the day, these are chemical-based dye solutions. So there is, if you're using like caustic materials or even like other solvents like isopropyl alcohol, they can cause like some of that chemical bonding to break down, and you'd see dye bleed on the part. So if the mineral oil probably would have pretty low impact, it's just going to come down to the rest of the environmental conditions of, how hot is that oil and stuff like that. But for the most part, it's pretty robust. But again, if you're using a solvent that might interact with it, it could cause some rub off and transfer.
Okay. Can you briefly explain the difference between auto loading and manual loading power fuse systems, workflow for each?
Yeah, so they're really just that. So with the auto loading, unloading feature, the Power Fuse Auto, basically, it is a programmable system that allows for one processing unit inside of the system and four loaded up, set up automatically to run. So you can go in the system, program 5 total builds basically, and it will run, it'll automatically unload what's in the chamber, push it off to the right side of the machine, and automatically load the next chamber in line, and it'll do that up to, I said, about 5 times. Whereas the manual loading, you still have like this nice, easy to use operating table in front of the system, but you're doing all the manual unloading. So you're only going to be able to program one run at a time.
Great. Do you see much difference in PA11 versus PA12 parts from the DM60?
From a color standpoint and processing capability, not so much. Again, like the biggest difference we're going to see in the DM60 is, are you starting with a white-based part or a gray-based part? And then with that in consideration, like especially on the gray-based, we don't see too much of a difference because of the material colors. They're gray to start with. Whereas on the white-based side of things, if you're messing with the material like EOS's PA2200, it's a nice bright white material versus their PA1101, which is a slightly yellow, more natural tinge to it. The same color being applied to both of those materials isn't going to produce the same result because they have that slight difference in color tone to begin with. But otherwise, they process pretty well the same, because there's temperature differences between each materials. The process temperatures are different, but otherwise, from like an operator standpoint, you're still doing the same easy scanning an RFID tag for the cartridge and pressing play, essentially.
All right. Looks like the next couple of questions are probably for you, David. How many cycles did it take? Did you process all the parts at once, or did it take multiple cycles?
So we actually broke it down into 2 or 3 smaller cycles. We technically could have fit it all in one cycle, but this geometry, specifically the clips you can see on your screen, the little fingers, they tend to grab onto each other and create a really big ball. So we found that breaking it into smaller batches led to just better results during powder removal. It was really important that the powder got removed from each of those little fingers because they snapped in, and it worked great. I mean, we could have left it in longer, But I think it actually was more efficient that we broke it into a couple smaller 2 or 3 cycles to process these parts.
Okay, next question. How long after dyeing the parts could they be used?
So yeah, it kind of depends on what your application is, but there's no residual dye or anything like that. It's just residual moisture on the surface of the part. So we did it in the afternoon and let them dry overnight, but if you needed to get to them quicker, you could apply a drying method or fan or something like that to get them, 30 minutes to an hour or so if you really wanted to.
All right. I don't see any other questions here. If anybody wants to quick throw one in. Otherwise, we appreciate everyone joining today and for your questions. And we'll send out the full recording of the webinar, so keep an eye out for that. And we hope to see you guys at the next webinar. Thanks, Lester and David.
Yes, thank you for having me.
Thank you, everyone. Have a good day.
Bye.
Bye.